is the concepts of IoT, and it's a short video, so please listen.
এক্সকিউজ মি, ভিডিওর সাথে সম্ভবত কমেন্ট্রি আছে, কিছু শোনা যাচ্ছে না।
না, আমি কমেন্ট্রি এখন কিছু বলছি না, কমেন্ট্রি দেব পরে।
না, ভিডিওর সাথে কোনো অডিও নাই বোধহয়, না?
সরি, আপনারা বলছেন যে অডিওটা কেউ শুনেন না মনে হয়।
না, আমরা আসলে অডিও শুনতে পাইনি।
Okay, it's not important. I think the visual highlighted some of the concepts of IoT. The first thing that was presented is about things, about sensors, gateways, devices. These are all connected over some sort of connectivity for data transfer. And we saw there that there were things that were being connected either at home in a wired environment or outside in a wireless environment. There is a lot of data processing going on, and data processing happens in the cloud. We saw the data warehouse with storage systems in there. And from all of that comes, there were some process involved in there around data protection and security. Telemetry for data visualization, some analytics in there for data insights. And we saw also the markets in there. There were some consumer markets for home, for personal use, and also some industrial in terms of cities and manufacturing. So these are the key elements of what an Internet of Things are. And in the next sections, I'm going to talk a little bit more about all of these things in detail. Now, when it comes to the Internet of Things, there are many different definitions depending on who you speak to. And so there's not a standard definition of what an Internet of Things is. But in summary, we can think of it as a connected network of things, and not only things, but also people and objects. And we are collecting data out of all of that, and we're sharing data about the way that they're being used and the environment they're being used in. So as the definition, as the name says, the Internet of Things, it is a connection of elements, objects, things, and information sharing. Before I proceed, there should be some definition of what IoT isn't. And there are some myths about IoT as being some sort of a new technology that's going to take over the world with machines. So just to put that myth to one side, let me see if I can take this out. Yeah. So if you've seen the movie Terminator, you'll know what this slide, what this image is about. So IoT is not going to be like Skynet, take over the world with machines. IoT is also not IT. IoT is about connecting physical things, whereas IT is about connecting digital assets. Although there are elements of IT and IoT, they are distinct fields. Another thing is the IoT sometimes thought of as M2M. IoT has some origins in M2M. So historically, it started out of M2M concepts, but it's very different. And M2M is about disparate systems, systems that don't talk to each other. It's about limited information, and it's about proprietary information. Whereas IoT is about open technology, it's about big data, it's about interconnection of systems. We also see that IoT is not an innovation, but enables organizations to actually benefit from technology. So IoT is not a driver, but an enabler of change for businesses, for creating new ideas and new value for its customers. And similarly, we don't see IoT as a single technology. It is, as we'll see today in the lecture, a combination of a number of technologies that are brought together and leverage as technologies for building a better business and better world. Before moving on, let me just also talk about some of the terminologies you'll find within the Internet of Things discussion. The first thing is about the differentiation between what a consumer-based IoT and an industrial-based IoT is. Um, Conceptually, they are both the same in terms of you have things or devices that have some intelligence uh, and ability to sense the environment using sensors. But it's beyond that what happens. So in the consumer world, you're consuming the information straight away. It's small bits of information that are quite personal, and it's intended to make our lives more convenient and easier. Whereas in the industrial space, we have more data, more volumes of data, and more insights from that data that allow business leaders and businesses to make uh, informed decisions based on what that data says. Um, so in terms of the interaction, industrial IoT is more business to business or business to consumer space. The other phenomenon is Industry 4.0. And here, Industry 4.0 sometimes is confused with industrial IoT. But Industry 4.0 is more of a philosophy. It's referred to as the fourth industrial revolution and encompasses business processes such as lean manufacturing and factory digitalization through the use of cyber physical systems. Another new concept, which is kind of surfaced in the last year to 2 years, is the notion of automated IoT. So this is application of artificial intelligence to IoT towards a more adaptive and autonomous systems. So if you can think about self-driving vehicles, where you're using the information from around you and the vehicle is learning and adapting itself and managing to control itself. That's an example of an AIoT system. And then there's something called the Internet of Everything. So the Internet of Everything expands on IoT and it brings people, process, and data things together. And lastly, this Web of Things. The Web of Things has got very little to do with the Internet of Things because it's not dealing with physical systems. It's more about practices, architectural and software practices that allow us to present real world object information into as part of the World Wide Web. So we can see the relationships between all of these things in this diagram in here, and you can see where IoT fits in and where the other concepts fit in. And some of them just fall just outside of what IoT is because they encompass other areas such as I4O. So where did IoT start from and how did we get here? If we look at the history of IoT, the first terminology or the use of the word Internet of Things is actually not that old. It's about 20 years old. And it was framed by a gentleman called Kevin Ashton at the MIT in the US. And going in that 20 years, we haven't seen IoT in terms of, we've seen the evolution of IoT in terms of how it's applied and more of a convergence with other technologies like artificial intelligence and cloud computing, advanced technologies like 5G. But the concept of connecting physical systems using the internet or using some sort of connectivity isn't new. And we can trace back to 40, maybe even 60, 80 years. But the real, first of all, in the way that modern Internet of Things is understood, one of the first applications going back 40 years at Carnegie Mellon University in the US, where they connected up a vending machine that gave out Coca-Cola bottles, and they wanted to remotely check for the vending machine content. And so that's one of the early examples of Internet of Things application. And of course, the World Wide Web hadn't been uh, uh, released at that point, so which came about 7 years later. So the notion of the Internet of Things hasn't been conceived, but from a technical point of view, that's how it worked. So why is IoT important to us? So let's look at what's happening around the world in terms of technology adoption, and this is from a research from a major marketing research institute. I think it's from Gartner, and it shows that the Internet of Things is the topmost concept or technology that is being used and adopted and is having the biggest impact from a economic point of view. And it is everywhere around us. If we look around in our personal lives, as well as in the industrial and commercial environment. And so we can't really ignore it. And we'll see in another image that the countries that are adopting it are the ones that are benefiting economically most from it. Now, you may have already heard that data is the new gold. And in the IoT case, this is really the crux of it. In the next 5 years, we can think of, and it is projected, so no one knows actually how much data will be there, that there was going to be around 27 billion devices that are connected. Today, there's estimated to be around 20 billion devices. So the population of the world is around 7.5 billion. So you can think already the number of devices has exceeded the population of the planet. But in terms of the amount of data, it's been projected that we will have around 2 zettabytes. That's 10 to the power of 21. If you want to sort of estimate how many zeros that is of data, and it's projected to generate around $3 trillion for the UK for the global economy. So I mentioned earlier that the countries that are adopting fastest IoT as having the most influence in their economy. You can see the developed countries are the ones that are actually taking this, and there are some emerging countries like Brazil and India that are starting to come into the picture as well. So those that have recognized the potential of the Internet of Things are benefiting already from it in their economy. For a country like Bangladesh, this is actually a good space to be in, because the majority of IoT applications are although it's based on physical devices and systems, most of the so this is, as we go from physical systems to digital systems, it's not a surprise. And with the skill sets and institutes like the Khulna University, we can see there's the huge potential for benefiting from the talent pool and adopting Internet of Things. So let's move on to see how IoT works. And you may have already seen this in many of your either publications or materials. Essentially, there are 4 areas or four blocks for IoT. And the one end, you have what's called the things. So these can be anything from home equipment like a fridge or air conditioner or HVAC system in a commercial environment, to more industrial things within construction, within security and other areas. And these things that have to have some way of sensing their environment. And the way that these things become smart is by having sensors added to to the things. Now, the problem with the work today is that many systems, especially in the industrial space, have things that are 30, 40, even 50-year-old, and they don't have the sensing elements. And so for these things to be made smart, we can add sensing components to them and allow the things to have data collected from them. And once the data is sensed, it then understood. And in order to understand that, we need to transport that data somewhere, whether local or in the cloud. And the medium or the passage for transportation vary either depending on the smartness of the thing. So a thing may already have within it some mechanism for communicating to the internet, or if it doesn't, it can go through an intermediate like a gateway or a smartphone, and those act like bridges or relays to go to the cloud. Once in the cloud, which is the middleware block, you have a number of elements for data storage, data processing, manipulation, analytics, and from there, we create the value applications, the telemetry, the visualization, the smartphone apps, the web applications, which allow users to interact with the system, and it's a two-way communication. So users can interact on the application, reach out to the things, control the things, and get information back and feedback from there. In most cases, things will be analog sources, data sources, but it can also be people and objects such as buildings. And here you see an example of a whole host of things in there. And I mentioned some of these earlier. And the things, as I said, are made smart by having sensors and actuators augmenting them. And what these kind of sensors do is, as you can see from this wheel, is it collects various types of information like vibration, temperature, position, motion, and so on. And there are hundreds of sensing elements. If you think about the human being and the number of senses it can pick out, we can have sensors for as many different types of equivalent types of sensing components. In terms of the anatomy of a thing, here we have an electronic circuit board. Most things comprise of an electronic circuit board. Depending on how complex the thing is, you may have more of a complex electronics in there. So essentially, what we start off with is a computer, which is the brainchild of the things and processes all of the information and controls all of the electronics on it. And some sort of storage for holding the information about this from the sensors and the environment around. We also have some sort of power source to manage the thing. And of course, the sensors. Without the sensors, this is just another, I call it a dumb device, but it's not obviously, but it's not collecting information about the environment. And so we don't understand how, from a human perspective, how this device or thing is performing. So the CPU, the computer, will translate the analog information through the sensors into digital information. And this digital information is then communicated to the outside world using some sort of a connectivity option. And there are a whole host of different connectivity options, like from a cellular to Bluetooth to many other ones, which we'll talk about later. And to make all of this work, you have some additional components on the electronic to get this all functioning effectively. Now, one of the most common electronic boards used for IoT is a single board computer, like here. It's called the Raspberry Pi. It's quite affordable, cheap, and you can do. You don't need complex equipment around it. You can buy components and modules and stick it on top and make it bigger and bigger. But the problem with this is that not all, I mean, this is quite big, and not all IoT devices are big, and some of them are really, really small, smaller than even a coin. For example, you can get a little IoT tag to keep track of where you are and get that information back to somewhere else. So in the building blocks, we talked about gateways, and gateways are allow IoT devices and things to communicate to the outside world, particularly in an environment. If you think about a factory, in that factory you will have things that are placed across the factory, and it's not always possible to reach, for example, a signal inside the factory. And so you can't get that information out. So what happens is that you can have a gateway, which is a device like a networking device that allows that information to be collected, to be locally processed, and to be communicated to the outside world if required. Now, this is more than just a networking component. It has computing capability, and depending on how big the heavy duty the gateway is, you can possibly do complex analytics on the factory side, on the site, if it's a smart city, on the equipment itself, and carry out a feedback loop in there between the thing and the gateway. And lastly, the gateway also provides a way for making sure that the devices, the things, have a degree of security. So if you're allowing the things to directly connect to the outside world, it's possible for someone to carry out some sort of malicious attack on that thing. But if you have a gateway in between, you're creating a layer so that that thing is protected from a security standpoint. So just to provide some clarity in terms of what a gateway is and how it compares to other networking elements, in a direct sense, you may have the thing connect with a modem or some connectivity in there. If you don't have that, you can either route it through your IT infrastructure with a router that has some sort of a modem component. But the problem with these two approaches is that they don't have intelligence at the edge to do things like manage the devices and carry out analytics and device management on there. But a gateway has support for more protocols, more connectivity options, and can connect to the outside world beyond what your traditional routers or switches can do, because these are usually typically based on fiber or Ethernet, whereas a gateway, you can use a cellular component, you can use a satellite, you can use broadband fiber, and locally, a gateway can support connectivity using a number of different other mechanisms. From a connectivity standpoint, traditional connectivity is using wired or wireless LAN, and we have these in our homes or in our offices using Ethernet or Wi-Fi, or in some manufacturing environment, field buses. And then you have some short range connectivity options like a Bluetooth or a RFID. Your phone, for example, will have NFC, so you can use that, or using contactless. You can do things like RFID detection. And they are used for connecting in short ranges up to about 100 meters or with the device. And if you go beyond 100 to 200 meters, you lose connectivity with your device or your thing. For more long range, you adopt cellular technologies. All the technologies like 2G and 3G are going out of support from the network operators, and now newer technologies like 5G are coming, which is going to provide support for big data and also for large data bandwidths. So you can imagine with that kind of compute, it's going to need those things to have a lot of power. Most things are battery powered. So, because it's wireless, they don't have additional power source. So things like 4G is quite power hungry, and so not very suitable for many IoT applications. And for that, there are other alternatives, low power wireless technologies, things like LoRaWAN, or even cellular and LTE, M, and narrowband, and they give longer range as well. But they don't support the big data bandwidth that cellular 5G would have. And so you have to think about what is your IoT need in terms of connectivity. Do I need to do big data or small data, but more in low power in constrained areas? So if you think about, for example, in a remote location like a farm where the cellular towers are much wider apart, and you've got a device in the farm, and it needs a signal, in which case a 3G or a 4G signal may not be the strongest element, so you might do something like a narrowband technology in there. But beyond that, and satellite technologies are much more expensive and much bigger, but they are for really remote locations. If you're thinking about, for example, you're on a ship or in an oil rig, you can use satellite technology to communicate, and but those are very big industrial applications. So this table kind of is summarizes. I'm not going to go through in details, but as you can see, the two key takeaways is that you have a licensed spectrum and you have an unlicensed spectrum. Unlicensed spectrum is usually in the sub gigahertz or in the low gigahertz frequencies, and the range is quite narrow. The bandwidth it can support, as I said, is quite narrow, but supports longer battery life, whereas the licensed spectrums support much more bigger data and but more power hungry, and also cost more in terms of the solution. So the third component is the middleware component, and it has three elements on it. The connectivity component. So when you're talking about something like as wireless connectivity, cellular connectivity, there is an intermediate platform through which the data has to flow through. So there is a connectivity management, and then there is the IoT components itself. You'll see that it has the IoT engines and other components around that, and the applications which are hosted on the enterprise cloud. So the connectivity management manages all of the communications between the IoT device and the endpoint. And the endpoint can be cloud services. It could be other data centers that belong to the business. And so it provides the infrastructure to connect between the device and the endpoint. It also provides a level of security for the devices and how the devices will be used for the components by the service in terms of identifying, hey, is this device allowed to be on this network? Do I recognize this? So when that device comes or the thing comes online, similar to what you do on your mobile phone, when you switch it on, if your network isn't there and you don't get a signal, or you get a signal but you can't get onto the network, it's because you're trying to connect to another network and that network is saying, you're not allowed on my network because I don't recognize you. In the same way, a connectivity management platform can provide that level of security to allow devices to get on the internet or not. And then you have the core of the IoT engine. And the core of the IoT engine provides a number of key functions for IoT. For example, device management. So providing remote software updates to the device for security patches or diagnostics and troubleshooting in case something happens. It also allows for real-time alarms and notifications and configuration management so that if any of the parameters or the things settings need to be adjusted, we can do it through the IoT engine in the device management. It also acts as a data broker. So all of the information that's coming into the cloud needs to be translated, understood, and managed so that other services within the infrastructure can understand this data. Not all IoT systems have data analytics, but in the industrial space, you will have data analytics, and data analytics allows for processing of information that is in real time or data that is stored so that we can create data models of what's happening in the environment in which the thing is operating in, and we can take some preemptive actions to correct if things are going wrong, or we can get an understanding of how that environment is operating. So if I'm a business owner and I've invested in a digital infrastructure, I can see from the data how well my systems are working. Do I need to get value-added services? Do I need to get extra warranty? Is the system performing to the way that it was advertised and sold to me? So we can get a lot of information and insights from the data, depending on what that data is coming through from the environment. If the data is of poor quality and it doesn't tell us much, we won't learn as much. Key to any IoT infrastructure is security. So there we have security of the assets, security of the data, security of the user, so identity and access management, network security, infrastructure security. So security encompasses end-to-end. And because now you're dealing with physical systems, you don't want your things to break down, people to get into your homes or your businesses and take control over all of your physical assets. Once an intruder gets in there, you have no control or no knowledge of what else is being taken control of. Now, to manage all of this, we often don't think of IoT as needing the operational element of it. And this is where the IT components of that I mentioned come in, although in the way that IT normally manages it, it is adoption, but adjusting it for physical systems. So here we're talking about how do you take a device, make it ready for deployment into the environment, into the factory, into the fields, and how does that device then automatically come online and get recognized by the cloud applications and systems. So the purpose of the operational elements is to ensure device lifecycle management, manage the connectivity, manage the provisions, and so on. And then you need some sort of services that orchestrates all of the components. So you have IT elements, you have analytic components, you have security, you have device management, and there are lots of separate systems in there. And you need something that sits above all of this to, like a puppet, manage all of those components and orchestrate systems and data around that. Lastly, to make all of that information available to the users, we need some way of normalizing the information. And we can do this through the use of an API gateway. And an API gateway, we can abstract that information. We can add security levels in there. We can create standardization of the data so that that data can be adopted and used by third-party applications. We can also link to third-party applications for a two-way communication and do a translation between the messaging that that third-party system can provide and what the IoT systems can understand. And these third-party systems can be anywhere from business support systems to production environments to financial systems, anything that really makes a typical business function. We're now connecting all of the physical assets and information into digital and into our traditional IT enterprise cloud applications. So I talked about a little bit about communication, and in the IoT world, this is really, really important. If we can't understand the information in there, we cannot translate the data. The data comes in various formats, and some sources try to create their own proprietary. And so if it's like holding a conversation, if one side speaks one language and the other one speaks another language, and you try to communicate, neither side understands each other. So we do need some way of communicating. And this mechanism are through messaging protocols. I've highlighted some of the more leading messaging protocols in here. And the most common IoT messaging protocols are MQTT, REST, and MQTT is very lightweight. It is open standard and has some elements of security built in, but it's not built in on top of it. So you do need to do some customization on it. But it does consume a lot of energy, which means that if you are using a low-powered device, MQTT may not be the best option, in which case you can adopt something like a Iot Technology or LWM2M, which stands for lightweight M2M, which are designed specifically for IoT, for low power, with built-in security, but these are not suitable for big data, for example. We now move into advances in IoT technologies. Now, as I said, and one of the earlier ones, that IoT is all about data. And if we see what are the reasons that people are adopting IoT, technology doesn't seem to show up in here. Efficiency, revenue, risk, cost, these are business functions. So how can we, from physical devices, understand and translate it into these business decisions, business factors? So on its own, having that data is a little bit meaningless if we can't translate this into things that make sense for the business. So this is where artificial intelligence comes in. Now, artificial intelligence, as we know, needs data, is very dependent on data. And so together they are really complementing each other and to create uh, insights that allow industries to take intelligent decisions. And from a business point of view, we can generate new business models and services around that. The next one is edge computing. Now, edge computing on its own is not a new technology as such. Is what it's saying is that for many applications, uh, sending all the data to the cloud doesn't make sense and has some drawbacks. When the data leaves an environment, it's open to security problems. You have to have the cost of the connectivity. There is a latency problem in terms of timing. So if you're relying on a real-time system in a production environment, there could be some delays of data going from A to B. And so cloud computing isn't always necessarily the best option. What edge computing concept is about is bringing a lot of the cloud computing elements much closer to the things in the sometimes completely off grid with no connectivity on site on the premises of the environment. And so this addresses many of those issues and addresses things like latency, data security, cost of the data connectivity, and better performance. Now, the problem with having some edge computing is that, of course, because it's all remote now, and if it's completely cut off, you don't have the benefits of being able to remotely manage your edge devices. Typically, edge computing comes in the way of either an advanced computer or in the gateways. So a lot of the functionality you can find are on the gateways. And you can add computing processing. The more computing processing you put in there, like putting graphics and GPUs, processing units, you can do more complex data crunching and analytics. And you can bring in more data in that sense and process it. Again, has some limitations in terms of how much of an analytics you can do, because the more data you have and more sources of data you have, the richer the data analytics will be and the more accurate data analytics will be. So there is a trade-off between the quality of the output and convenience. So immersive technologies is about providing, augmenting your local physical devices and objects with the ability to create a virtual environment so that you can see and feel from a remote distance what your physical environment can do. So from a IoT perspective, this has many benefits. For example, deploying IoT and immersive technologies allows us to quickly model what that environment is and understand the way that the systems work, and thus help reduce the cost of deployment. So you don't have to go out and develop and deploy your solutions in advance. You can model it in the digital way, and you can see it, how it's going to perform, and deploy it accordingly. Now, digital twins is another technology that is often associated with industrial IoT. And digital twin is essentially an exact copy of a physical object or a process, and involves digital profiling of the behavior of the physical objects and processes. So Again, similar to immersive technologies, where immersive technologies allows you to interact with the environment in a real way, digital twins allows you to model out and understand how your systems can be optimized um, and understand interactions between not just the environment and the things, but also your entire business process. And so you're able to create your business operations and how it should be before you actually go ahead and do it. Okay. Now, because we're now moving from a physical and analog space to a digital space, the way that IoT businesses work is somewhat a little bit different. So in the traditional sense, you have transactionals. So I go into a shop, I buy something, I consume it, and that's the end of it. Okay. Now, if someone wants to understand how is that, what has been my experience, they won't necessarily get that information. Or if they do, it's a single point of data. And so when businesses try to decide, is this product good for the market, they have the amount of information they have is quite limited. And so therefore the ability to scale is either slow or limited. On the other hand, with IoT, there is a more of a personalization in terms of the information that you're getting back. So if I take, for example, a smart vehicle, now a smart vehicle will have lots of IoT elements in there. It will have digital components, how my vehicle is being used, where am I going, how often do I change my tires, or how often do I change the fuel on it, and what kind of locations do I go. All of that information can be gathered, and then from a business point of view, I'm a business owner. I can say, okay, my customer is using this product in this kind of way. How can I provide more uh, targeted and more tailored service to them? So we're going from physical transactional models to more of a service-oriented model in here. And the models in here we can have are subscription-based, where someone buys a service, and then once a month or annually, that service gets renewed, and so the service continues in there if I want to continue that service. But it can also be outcome-based, and so if I'm buying, for example, a drilling machine. Now, why do I buy that drilling machine? I buy that drilling machine because I want to drill something. Normally, when you sell a physical product, you're selling the drilling machine. But in the IoT sense, what you're interested in is, what is my customer drilling? Okay, so if I'm drilling, for example, some metal component, I need drill PCs, I need the rivets, I need the nuts. So then I can go and say, okay, the drill is bought one time, and this customer is not going to need to buy another drill for maybe 5 years. But what I can start to sell them is, hey, I can sell you service. I can sell you all of these nuts and bolts and all of these components that you can see. Okay, so you can see how we start to look at IoT from a different perspective. And so instead of selling a drill, which as a business, I might say, okay, I'm just going to give this drill away. A drill costs maybe, $100. It's a lot of money. But if I can sell something to this customer for 3 years, and that will generate more than my $100. And so every time that drill machine is used, I can say, okay, for every drill that you use, every time you use that, you pay me maybe 1 cent. And so you accumulate that in there. And from a user perspective, you're paying for exactly what you need. And you can think of it again, going back to your mobile device, you are paying for data. And how much data do you need? You don't pay for just a smartphone, you pay for the services on that smartphone. IoT is very, very similar in that sense. IoT is not without its challenges. The top challenges in IoT are scalability, security, and connectivity. Scalability, because a lot of the times, we're dealing with systems and devices that are not that many, really. And when you go to operationalize this from an infrastructure point of view, whereas in an IT sense, you're talking about hundreds of thousands of devices. In an IoT sense, you're not that many. And so from an operational point of view, it poses some challenges in there. What kind of cloud computing resources do you need? Do I need to put in system monitoring in there? And in the local sense, do I need to put some extra cabling in there? And if I do, add new devices, how much more in terms of floor planning do I need? So there's a lot of scalability issues in there that we can't foresee or predict. I've mentioned security a lot already, and security still remains one of the key components and challenges for IoT, primarily because, as I said, a lot of the things are still legacy, old, don't have security components built in. And so to manage all of that, uh, we have to address that either through some local measures or in the cloud, and or through some digital means through protocols and messaging. And lastly, we've seen earlier on the wide range of connectivity options in there, and that requires understanding of the connectivity environment, um, the data consumption, the security requirements, how the data will be used, and so even the complexities of each of the connectivity. So, for example, if you're talking about cellular, um, if you sign up with one network provider, and that network provider doesn't have to happen to have a presence signal in a particular kind of area, then what do you do? So you then go in to start talking about taking on connectivity with a multi-provider or a roaming profile. And in that sense, from a technical perspective, things get a little bit more difficult, because how does your device know which operator to use? If one operator isn't available, how do you switch to another operator, and so on and so on. So move on to the last section, which is the IoT applications. And here, and I'm trying to highlight in here, what are the globally, what are the areas in which IoT is being adopted for? And we can see the industrial space in general, whether that's manufacturing, transportation, retail, cities. These are all industrial areas or commercial areas, and they are the sort of the leading application areas for that. Just to take you through some of those, I won't go through every one of them. And these, as I said, these are only the top 10 in there from market research for 2020. In the manufacturing space, things break down. When things break down, production lines stop. If production line stops, it costs money to repair. Sometimes repair takes a long time. You have to bring in the expertise. You have to call the service company. And so IoT can help the manufacturing space understand from data what's happening. Data analytics can provide predictive analytics. Operators can see into from the data is likely to happen in the future and make some plans accordingly. They can see how their systems are operating in terms of the machine health, and react accordingly in a proactive environment. But also from a logistics and asset management, it allows a top level view of what's happening in a manufacturing environment. So many manufacturers don't only have one factory, they have many factories, and you want to see globally what your what your environment, what your business is doing. Things move from one area to another area. You want to see how your assets are moving in between there, how the supply chain is moving, and so on. And of course, we talked about managing all of that, managing the workforce, connecting up your digital systems with your processes and with your people, and linking it all together in a more of a optimized way. And then you can also have energy. IoT applications and energy is for energy management, understanding how energy is being consumed, detect wastages in energy, allows management of energy companies to optimize how they lay out their the grid, where they take actions in terms of the different operational scenarios. Can they utilize more clean technologies in some areas to gain efficiencies, and therefore get a better picture of and better management of the infrastructure. Now, in some also areas, we have governments that are subsidizing IoT projects like smart meters. It provides an insight into their return on investment. The theme of this workshop is cities, and in smart cities, various aspects of the city functions can be linked through IoT, from traffic management, lighting, parking, public safety, and even things like managing noise pollution, air quality, and managing the road infrastructure and so on. Retail is another area. In a retail environment, IoT can help business owners understand how how their consumers or customers are experiencing in the retail environment. They can automate some of the processes like self-checkouts. They can manage the supply chain when goods start to go down in stock. You can have IoT systems put in place to detect that and put into place some automation in terms of the supply chain, and provide a more of a personalized experience for the consumers. Another application of IoT is in agriculture. So within agriculture, there are many concerns. For example, utilization of energy, utilization of how the weather system functions, and how that affects the yield or the quality of the crop, in terms of being able to remotely manage a lot of the capabilities in there. So keep the farming environment free from disease and free from infection from pesticides, but also if you've got cattle, you've got livestock, you can see the health and well-being of those that livestock. You can also manage the irrigation of it through better water management and better understanding of the greenhouse in terms of how
Sorry to interrupt, Mr. Munir. We have some other speakers. Please, can you finish it quickly? Thank you.
Yeah. Okay, so I'm just going to skip over the IoT skills. So this is basically the IoT skills that you would need. It's a lot of new technologies, but it's from front and back. I'm just going to end up on just 2 minutes on a demo in here. So this demo is on an irrigation. As you know, in farming, getting water supply and getting effective water supply is an issue. But in some areas you have pollution due to diesel powers, diesel pumping machines. And so what we can use is clean technology in IoT to improve that. And here in one of the examples that I have that I see, for some reason that didn't go well. Yeah, so based on that, we can collect some data information um, uh, and get an understanding in real time of what's happening with our amount of water being pumped, how it's being generated, the amount of energy that's being used. We can get the status of the devices and so on. And it provides us as with a global view of an understanding of our IoT environment. So I know I've taken a little bit more time than I was allocated, so I hope that's given an introduction into an IoT and some of the benefits of it, and how from a smart cities and smart farming and agriculture point of view, how IoT can help you. Okay, so thank you.
Please don't get confused. Mr. Anisur Rahman has not become Abu Shami Muhammad Arif with the help of IT. This is not the IT actually, this is real.
Yes.
So anyway, many thanks to Dr. Munir Chaudhary for his nice and live presentation. We have learned some new definitions, details of theory, applications, business, challenges of IoT. I think the researcher will be able to explore more. Our students will be able to implement something with the help of IoT. So I don't know your availability, but if you allow, then we can get some questions from the participants.
Yes, I can take some questions. Yes.
Please, কারো যদি কোনো প্রশ্ন থাকে, please.
Okay, I have a question. Okay, first of all, thank you very much, Dr. Munir Chaudhary. It was a fantastic presentation, and we have learned a lot in context of smart village or smart city. If you consider the IT area or ICT area, then IoT is the IT devices are the found devices in the ecosystem. And we, in our last few workshops, we always talked about the data science, data management, but we have now some ideas how our data will be coming to us so that we can work with the data. So my question is, what do you think? How there are a lot of IoT devices, as you have shown in your presentation, in many domains. So, which devices or devices from which domain would be applicable in a smart village context? What do you think, or do you have any suggestion for us that we should concentrate on that set of devices?
Yes, it's a good question. Thank you for the question. So, in smart village, you have people's livelihoods. So, if I understand your question, it is in the context of a smart village and not specifically in terms of agriculture itself. So in smart village, energy is one of the key issues, but also people's, so you have energy, you have education, you have farming and agriculture. So there are many angles in which you can address even transportation from a smart village. And in terms of collecting data sources, I would actually start with some small area that has a significant impact on the everyday life of the smart of the village. So, for example, getting clean water source. So, how can we get clean water source for the smart village? And in there, the example that I briefly showed, for example, is about making sure that you have water source that is available throughout the day, all around the year. And in some areas, you get flooding, you get water sources that get contaminated. So I think the best thing to do is, you have a big vision, but to start small and understand how that affects people's lives in that area. And then from there, you can start to expand out into the other areas of health and education and people's, environment. Because the way that you're going to see any tangible benefits is when people interact. And when people interact, you get a lot of data. And data means you're able to effectively model out that village in terms of its use. So just by seeing how people benefit from clean water source, how their everyday lives change, so they're not taking longer journeys to walk somewhere to get some clean water, or they're not spending more time within themselves to purify that water, for example. You get then to see the impact of that and how does that translate into everyday quality of life. So, it's a big topic. So if you want to talk about that offline, you can exchange some communication and we can talk about that a little bit more.
Thank you. Actually, our time is not flexible, so we can get only 2 questions more if you have, please.
So, Shamim, so what I would suggest, let Masoom finish, and then we can have a longer time for discussion or open question. Yeah,
Sir.
so that is what I would suggest, because I have a lot of questions to Munir, but since I have been thinking about our Masoom, so he's in Australia, it is already late night there, I believe.
Sir.
It's
So,
8:30 p.m. sir.
8:30. Okay, so is
Yes.
it okay with you? So better you finish
this
your
is-
talk.
This is okay for me because it is Saturday night.
Yeah, okay. So then my suggestion would be you finish the talk, and then I have a lot of questions for Munir. So I want to really connect you two together. So for the question, because, so most of our major application of a smart village will be relating to agriculture, where we'll be having a huge number of sensor device deployed in the agricultural field and collect the data, and then really it will be going to somewhere, to a data center or anywhere, and then we need to really use any data processing or data mining or what you call that, data analytics, and give the information to the farmer to a suitable device. So that is where the challenges are, and we need to really focus in our implementation in the future. So therefore, I have a lot of questions to Munir. To be honest, I didn't have any very basic or very in-depth idea about the IoT. And Munir's presentation was fantastic, and that really opened up a lot of problems or issues now we can really think of, right? So, so I would request Mustafa Masoom to really go ahead with his presentation, and really, so we can have the discussion at the end. So sorry to interrupt the session moderator, but this is what I felt.
Sir. Special thanks to Dr. Munir Choudhury. Please stay with us. আমাদের বাংলাদেশ সরকারের পক্ষ থেকে একজন স্পিকার ছিলেন আলাউল কবির, উনাকে আমি আসলে দেখছি না এখন পর্যন্ত। সম্ভবত
ওনার নাম্বার আছে মিস্টার গালিবের কাছে। গালিব একটু ফোন করে দেখা যেতে পারে?
গালিব।
হ্যাঁ, গালিবের কাছে থাকার কথা ওনার নাম্বার।
গালিব
কি শুনতে পাচ্ছ গালিব?
স্যার আমি গালিবকে ফোন দিব নাকি?
আচ্ছা, এই ফাঁকে আমরা মনে হয় যে অস্ট্রেলিয়ায় যারা আছে ওদের দিয়ে শুরু করি, আর গালিবকে বলি আমরা ওনার সাথে যোগাযোগ করতে, উনি যদি পরে। হ্যালো।
যে that's the best idea, good idea.
Then we can interrupt in between.
Yes.
ওকে, থ্যাংক ইউ। আমাদের এই পর্যায়ে আসলে বক্তব্য রাখবেন আমাদের রিসোর্স পার্সোনেল 4 জন। ডক্টর মুস্তাফা আল মাসুম শেখ,
আমি বোধহয় মেইল করিনি স্যার।
মোহাম্মদ জিলানি, সর্দার গুলজার এবং মোহাম্মদ মইনুল হুসাইন। এবং তাদের একটা বিশেষ পরিচয় হলো তারা খুলনা বিশ্ববিদ্যালয়ের কম্পিউটার সায়েন্স ডিসিপ্লিনের 94 ব্যাচের সবাই ওরা বন্ধু। আসলে বিভিন্ন জায়গায় ওরা দীর্ঘদিন যাবৎ আইটি ফিল্ডে প্র্যাকটিক্যালি কাজ করছে। তো তাদের কাছেই আমরা তাদের অভিজ্ঞতা এবং আমরা আজকে যে আমাদের স্মার্ট সিটি এবং স্মার্ট ভিলেজ নিয়ে কথা বলছি, সেই লক্ষ্যে তাদের অভিজ্ঞতা এবং তাদের নলেজ আমাদের সবার সাথে শেয়ার করবে। আমি মোস্তফা আল মাসুমের কাছেই আসলে কন্ট্রোলটা দিচ্ছি। এখন সে আসলে কিভাবে কাকে আগে দিবে আমি ঠিক বুঝতে পারছি না আসলে। মোস্তফা আল মাসুম।
Okay, I'm just sharing my screen. Just if you can confirm if you can see my screen.
Yes.
Okay, good. Yes. Thank you. Assalamu alaikum and welcome again. I should pay my special thanks for the audience for their vigilant presence and patient hearing, and at the same time extending my sincere gratitude and appreciation to the organizer, especially Siddiqui sir. It has been third time that we have been in this forum. The good thing about the forum is that we are, just Siddiqui sir is trying to keep different professions in a vortex so that we can think together, we can work together and come up with a realistic like a solution for smart city or smart village. So in that context, we have been interacting with architects, city planners, policymakers, like a business owners or business people, so that they can see the business viability out of it, engineering solutions, and finally IT like us. So as you can see, smart city means is the city is getting a smart, but actually the output of that benefit of the smart city is the people get smart. So we have to define what is the smartness of people. So given at this age, we are staying in the age of like an industrial revolution has been passed. We are in the age of IT or information or data or information. Sooner or later, we'll be in the fourth industrial revolution of AI and augmented reality like that. So now we have to define our position in this case before we think about a smart city. So where is our position? If we want to make people smart, that means their way of living their life in the village or the town should be very much smart, in a sense that they should be connected to what? Connected to the Americans, connected to the Europeans, or connected to their fellow neighbors. So what kind of benefits we will try to ultimately service-wise want to give? So from IT perspective, everything and all thing is possible. But so from that perspective, we have to definitely think what should be the goal. So before, as you can see, the smart city is a physical thing. It's just exists in somewhere, right? And IT as an enabler that works at the back end. But when it enables something, the service becomes available and apparent to the citizens. So that means the IT comes at the very bottom when we have all the infrastructures, all the plannings, all the things are there. So the motivation for us to present in this context, it would be too early, but thing is that we are trying to develop a workforce. So imagine if we have selected a venue, we have selected a place that should be working as our IT, like working as a smart town or a smart village, then we have to think, okay, we want to improve our agricultural ability, our agricultural control. We want to know more about like our people health. We can provide better healthcare, like telemedicine like things. We select the niche areas, and then we think about an IT solutions. So when we have the solution, then we are getting ready. So that's the whole purpose of our hands-on. Then we will show, okay, hey, developers or engineers, this is the way we used to do, and we will share our experience. And then we will basically want to steer the team in a right manner and right direction, so that we are ready from the very first day without any confusion. So the purpose of the presentation is basically on that aspect. We, as an IT enabler, want to make sure that things are like, we know the business, we know how to implement this IT solution. If we know the problem, we can crack it. So with that thing, we would like to thank our previous speaker who mentioned about the IoT, which is essentially the backbone of any smart village and system. As you can see from my slide, if you think about a smart community or smart hospitality or even a smart agriculture, nowhere IoT, without IoT, you cannot get data from the field. It's not, you are not getting data from a person calling to another person and sharing the data. It's not like that. It's getting data 24/7 through devices. So at the same time, we are getting data rich, but information poor, okay? So I just like to repeat this sentence again. We are getting data rich every day, but information poor. But through our data science approach or different machine learning approach, the AI approach, we want to make this movement, which is we are going to more information rich as well, not only the data rich. So with the advent of different different IoT devices, definitely we'll get a lot of and varieties of data. But we want to make information rich, but to make ourselves information rich as well, we need right technology in place, so that if we want to monitor people's health or monitor the agriculture, so if you get 10 sources of data set, then the whole 10 sources of data should have a good story to tell, which should be precise, perfect, and helping the farmers at the end. So with that manner, I would like to introduce our team who are very much qualified into this space of different IT systems and solutions. As my name is Mustafa. I'm working as a senior data scientist in eHealth, which is a health of New South Wales in Australia. And we have been doing a lot of jobs with the pandemic responses and not many hospital digital health. Basically, if you know the concept of digital health, basically that is my expertise area. So then I'll introduce our like a gang of the people. As I said, it's a 694 CSE batch, so we call them a gang now. Sardar Mehdi Guljar is one of the solution architect. He has very good experience. He's working with Fujitsu for a long time, and like he can build things from scratch. Then we have Mohammad Jilani. He's also working in the data space. Then we have very qualified, and all of them are very much qualified into the space, which is who is Mr. Mohammad Mainul Hossain. So is it a good idea? So if every one of our team and the gang could tell like one or two sentences about themselves, then I will share the agenda briefly in the next slide. So I would like to say Tuhin, because Sardar Guljar is known by Tuhin. So Tuhin, if you can speak a few words about yourself, then we'll move.
Thank you, Masum. So my full name is Sardar Mehdi Guljar, and my nickname is Tuhin. I think my teachers, and Shamim Bhai is one of them. Like they know Bhai, and Anis Bhai is of course there. So most of the people know me by Tuhin as well. So I'm working for currently Fujitsu Australia, and I'm working for 10 years here. So I'm working as a solution architect, and currently I'm focused with collaboration and automation solutions. So I work for customer and also the inside Fujitsu. And the main, if I think of talk about the automation area, it's about like making, like whatever is currently people doing, different business doing, we try to like, what do you call it, like fast track their process by automating things which are, like normally people are doing, or some like all manual work. So whatever way we can actually make it faster, that is our goal.
Well said then. Yeah, then Jelani, if you can briefly introduce yourself, please.
Can you hear me properly?
Yes.
Hello? Yeah. Okay. Yeah, my name is Muhammad Ghulam Jilani. Fortunately, I am also from the CSC 94 batch. I myself working with the I working in the copyright agency Australia, and my working space is mainly based on the strategic data and get the insights from the data. So whenever Siddiqui sir was discussing about the smart city and smart village, it closely aligned with my work field, because the things we are working at this moment is getting the insight of the strategic data for the company, because our company is having the client all Australian universities, states, and all government organizations to preserve their patent of the copyright. So we have the client all over the world, including UK and USA. And at this moment, I am working some projects based on the artificial neural network and one of the algorithm used by Facebook called Face. So using that algorithm, we are developing a system which can recognize image, which image can getting from the PDF file. Anyway, long story short, so the work we are doing at this moment is gonna be closely aligned with the system, or thinking is thing by Siddiqui sir. That's why this is our third session, and I feel myself very much honored and honored that I am in this platform, and my special thanks goes to Siddiqui sir that he gave me opportunity to speak in here. Anyway, since this is 8:45, I was thinking maybe this is a good idea after the discussion, introduction to four of us, then maybe Mustafa can go for with the coding level of explanation. Although I was preparing some slide and was thinking to show some code in our environment, but I don't think people will have enough patience until that time. So I request Manol Liton to introduce himself, and it goes to Mustafa Al Shaikh. Thank you very much, and thanks everybody.
Okay, here is Mohammed Mainul Hussain. I am one of the 94 graduates, and I'm an entrepreneur. I have a small company in Dhaka, and I work for Germany and Canada. And I'm also a project manager in a German company, Polytech GmbH. I have been working in this company for last 20 years as a project manager, software architect, and software engineering in various roles over the years. And for the company, I use IoT as a developer, and especially the optical measurement system devices. And I have another role. I am a senior data analyst in University of Saskatchewan, Canada. There we work with data management and data analytics system, where we apply data science, artificial intelligence, and machine learning, deep learning, all the cutting edge tools and technologies. And I thank you very much, Siddiqui sir and Anis bhai, Shamim bhai, who have been working with this initiative for smart city and smart village. I think some of my work overlaps with this area, and I'll be happy to continue my contribution to this effort. And I give it over to Masum.
Yes.
Masum, please continue.
Yes. Thank you, everyone.
Okay, you may call you a gang, but we think you are the boss. All of you are boss of the bosses. So special congratulations to you from the CSE discipline. Thank you.
Thank you.
We are very proud of you also. Okay, so in a sense, in a summary, what we would say, we'll be very humble to say that Siddiqui sir has collected all the jewels and gems and diamonds around the world to come into the same vortex to make something. Let's do it. Okay, so without much here and there, I would like to share the agenda. So previously we have spoken about the readiness of a smart city in the context of Bangladesh. So, and also in the morning, there are a lot of talks about that. So there is no doubt, we should not have any iota of doubt that we are still having lack infrastructure issues or any initiative issues, or anything that is hindering us to implement a smart city in the context of Bangladesh or rural area of Bangladesh. So now we need a solid implementation plan to do that. And as an IT enabler, I can tell you that you should have all kind of, which can give you all sort of confidence and support to do that. So today's session, I would like to talk about as a general architecture, like if you have a solution or a system, like eventually if you build up a agriculture monitoring system using IoT. So that's a system, right? And that should come up with a technical architecture. So technical architecture, when it has been developed, then you need to think about how to implement technology choice, because basically then it has to hit the ground, hit the rubber hitting the ground. That means it has to be really, really very much pixel perfect. So the choice of technology and the solution should be very much thought of in a way so that it is scalable, it is doable, and it is benefiting at the end. So in that aspect, I would like to tell Tuhin to share his experience and as an overarching view of a technical architecture. Given a system, like I just briefly skip through these systems. So that's the thing. The graph is basically showing you that it is showing us that we are ready in terms of data, in terms of information. Bangladesh is perfectly suited for any smart village implementation because we have a lot of network penetration and whatnot. People are using smart devices. So we need right application to capture this. So I just having a hypothetical application. For example, if you want to give health support to the citizen to monitor their health, because diabetics and health and the correlated disease is the COPD or the heart attack. So if you want to reduce that lifestyle disease, if we can tap them on their shoulder, like, hey, you are not doing a lot of exercise, you are not having a proper diet, hey, you are not monitoring your health for some time, just simple tap, simple message, simple monitoring loop should help them to at least get checked. So the be self-aware and self-consciousness we can build through simple SMS message. So in order to do that, there are a lot of ways, and definitely IoT comes in the picture, and also the smart devices they put on the hand. So having this hypothetical application and architecture in mind, I would like to tell Tuhin how he can implement this architecture in a real world scenario. So I am sharing his slides. So Tuhin, it's your floor now. So you can have like a maximum 5 to 10 minutes to run through the slides.
Okay. So as an architect, like one of the thing I try to always tell people, like whenever you start something, begin end with mind. That means actually whenever you start, I think Dr. Munir also mentioned one word, that your vision should be broad, but you start with a small. So the idea is like you have to be clear actually about your end goal whenever you start something. So that's why architecture is so important, because sometimes we just go for deployment or implementation of something, but because of poor architecture, it end up a failure. So, and many startup company in history, when the customer they got a lot of customer commercially, they starts to become successful, but because of poor architecture, they cannot cope with the market. So that's why we need to just give this idea. It's not about like what application you're building. You need to think about how actually a system will end up. So, and you have to be able to think about like different perspective of a system. So there is if you go to next slide, I think we'll just go. Yeah, so I'll just give this old view, which they call 4:1 view. Like, so whenever you think about a system, you should initially think about the logical view. That means actually how your system is working from a user point of view, kind of thing. Then also, again, with the logical view, you have to think about the process view. So different process, how it will start and how it will end. For example, I'm collecting a sensor data. For example, I was just doing some hands-on with my home improvement. And for example, one of the issue with my window is like whenever the sun is very, like hot, I want to close my, like what do you call it, the curtains.
Blind.
So, yeah, the blind here they call blind, obviously. Yeah, like in
Blind,
Bangladesh,
yes.
we used to call curtain, right? So,
Porda,
but anyway,
yes.
so the idea is porda. So, like you always don't notice the thing. So what you can do, you can just put a small sensor, and whenever the temperature beyond something, then you can just send the data and to a computer, right? And then in a computer will just put any logic. It can be just machine learning, or it can be just a fixed logic. Then it can send back something to a special, for example, you have a motor in your curtain, and it will just say run the motor, and which will actually close the window. So you see, this is the end-to-end scenario. So just, for example, a data coming from somewhere, either from physical user interface or a IoT device, automatically you have to use it, right? So any system, you have to think through this process. And also Siddiq sir was mentioning, I do actually a lot of vegetable gardening, and he was saying make it smart. I thought about that, but I actually made a smart, like I used to keep some chicken. I made it so smart. Then I actually lost the connection between the chicken, because I then don't care, because everything was automated, like the food and the, like the water and everything. So I just then get rid of them. So, but for my garden, I like to actually be with the plants, and like, so that's why I'm not automating, but I know what to do, because that's one of the thing, like I try to actually do thing practically to understand how it actually works theoretically. So that's the process view. So you have to think about this. Then, like whenever you know that this is my problem, you have to think about a solution, which is like how you are going to develop it. So that's actually the development view. And that comes with the, like language and tools and technologies and everything. This is your actually second level of thinking. So sometimes, especially for all the graduates and like new people, they start with this development view. They will introduce themselves. I am a C# developer, for example. I am a Node.js developer, but I never say like that. So I am like, my job is, for example, I am a software engineer. So I actually engineer thing, and sometimes I deploy thing with C++. Sometimes I do C#, and sometimes some other language. For example, last year during this COVID, I learned Node.js and then React and everything. So because of I developed a system recently. So you see, so this should change. You should learn. But obviously, some people do like core level of like engineering thing. For example, Liton, my friend Mainul Hossain, he works with so specific things. So that requires a special language. That's all right. But like normally people like us who are do practical thing, we should just like keep this vision separate. Okay, so the last thing I'm talking about, the physical view. So when you develop something, so you develop, right? You develop in a language, then you have to think about actually deploying it, because once you deploy it, then it can be used. And before, like, what you would do, you would buy a server, a lot of hardware, then you put the operating system, and like then you uh, deploy your like platform. For example, if it is a Node.js or if it is a ASP.NET, you have to put the platform in, right? Then you actually put your code. So that was the old school. But now what you can do, you can think about like, okay, I don't buy the hardware or anything. I can just take a machine from a provider, and then I go for like deploy my platform and everything. And even that is like a lot of work for a developer. That is a lot of work. You need some system engineers help, and I'll just quickly show you a demo quickly, like how it's different. And the third option nowadays, they comes with actually a platform itself. So you don't need to think about install your OS, install your platform. You just go for your code, and you just say, okay, this is my code, run it, and it will just run it. Okay, so that's the different point of view of a system you have to think about whenever you start building something. So Masum, if I have time, like, then I can just go for quick five minutes demo, quick.
Yeah, I think that would be good then.
Okay,
Yeah.
so but that means I
yeah.
need to actually share my screen, because I'm in a
Yeah.
computer.
Okay, then I unshare the screen, then you can share.
Yeah. Just give me a second. Okay, that's good. Yeah, I can share. So yeah, for example, I was just testing this. I wanted to actually do a proper demo, but obviously we did not test enough. But I want to just quickly show you. So for example, I was just testing a simple Node.js application. So obviously I am developing it in my computer. Here is it. I am running in a debug mode, and you can see I can just go and test my application from this port. So for example, this is a hello world. Now imagine I'm in old school and I'm deploying this in a computer. And imagine this is my server. So I have actually a physical desktop and I deployed it. But how I actually make it available from the outside world, right? So what I did actually, I'll just quickly show you. So even if you go for this IP address, I'll just put in the chat box. So just to, where is my chat? I got it. Just give me a second, it's struggling. So for example, I have a, like, it's not a fixed IP address, but I have external IP address. And what I did have to do, you need some, like level of help from a system engineer who understand the thing. So what I have to do, for example, this, in my case, I have a, like modem and router in the same box, and I can just forward a port. So in a real life situation, what you have to do, you need some network engineer, and they will actually come to, like, and then they will just, this is the virtual. So you see, like I put a quick port forward. So whatever is my external IP address is going to my this local machine. So this is a networking thing, but because I work for this industry so long, so I understand a little thing from everywhere. So the idea is, so you have to set up. So you see, for a physical machine, you have to buy a physical thing, then deploy your application, and obviously you deploy your platform and everything. Then you also need to set up this networking and everything, and also obviously the security and everything. So for example, here is a quick solution I did, but normally you will go for a network engineer and everything. Okay, so that's one way. So you have your physical machine and you deploy it. Okay, the second way you can do, as I said, you can actually like buy a machine or borrow a machine. So for example, what I did this is my Azure, like cloud environment. So what I did, I just created a machine, virtual machine, and what I'll show you in the background. So this is a VM I created, just a Linux VM. And then actually I connected, for example, copying the file, a tool, and you can connect to, like the common tool is like, what do you call it? Put something like, like
SCP. SCP.
SCP is the one, putty is the popular one.
Yeah.
So yeah, so
Yeah.
putty, you can connect to the machine and you then do everything from this, so you deploy your Node.js platform, and you can see I'm struggling. I was actually testing and there was some issue. So you see, like a lot of work, and it's not only that work, and but still it's better because you don't need to buy a machine. You just created the machine, and what it did actually for you, I'll quickly show you that it created so many things that is actually beyond your like capability. Like for a developer, we can just create it, and you can see you have your virtual machine, but obviously it assigned a public IP address, so you don't need to do anything. You will get the machine available externally. Then it created a many thing internally. You can see it's a disk, and like 1, 2, 3, 4, 5, 6 things, which is automatically created when you just created a virtual machine. You see, like, so what in physical world in earlier days, everything has to be created manually. So you need the skill set out, like every area. But now it automatically created for you, and you can just quickly configure. For example, if I want to open a port to external thing, you can see it has all menu driven thing, and obviously you can automate, you can script it and then automate when you repeat the same thing. So you see, so that's the second way, right? So it's still a lot of work. So you create the virtual machine, you configure the port, and like you have to obviously go to the machine through some tool, and then you deploy everything. For example, you have to deploy the Node.js, then you have to like you need to run it, run the application, like you have to do a lot of stuff still. So that's actually called infrastructure as a service. So first one was on-prem, we call it, because it is on your premise, you buy the server and you do everything whatever is necessary. But for here, you just buy a machine, and you can buy multiple, and you can do a lot of setup, like you can put a load balancer in front of it to make it high available, and obviously balancing the load, and like do all sort of stuff. And you can do DR in a different data center, and everything is very available in cloud. Okay, so the third way I want to show you, as I told you, that you can just go for a ready-made platform where you can just deploy your application quickly. And you can see, when I was trying to do it on a VM, I still struggle and I could not finish it. I would need a lot of time to troubleshoot and find the issue and everything. But when I choose this option, now I'm showing a Google platform. Obviously, this same thing is available in Azure and also the AWS. But you can see I'm just having an app engine in Google. And what I had to do, quickly build my application. And you can see there is a tool provided by Google. I just said this command, and what happened, it deployed the application here. And you can see it also not necessarily just a public IP address, it also give a friendly email, friendly address. And if you can browse it, you can see it's already deployed. So you see how quick it is. You just create a application which is just a one-click thing, and you just download this tool, the Google Cloud Console they call it, and then you just put a command. And obviously, just for this, you need just to configure one file. For example, this is the file you configure to tell the Google thing that this is my target environment, and there is some setup for like a Node.js application to run successfully. But you can see how easy it is. So that is the point actually. Like, I wanted to show you that nowadays you have these many options, and obviously depending on your situation, you can just choose any of them. Back to you, Masum.
Okay,
Masum, are you there?
thank you. Yes, thank you, Tuhin. Yes, I think that's a very good, like a kind of a hands-on, just given like a view of the tip of the ocean, how things could get wild and could be flexible enough. So in that same light, I would like to continue further to give you more experience, like a more hands-on. So just share my screen, then I'll talk. Okay, so I'm back here. So the hands-on, as Tuhin has mentioned about cloud, so there are a few things like infrastructure as a service, software as a service, platform as a service, even analytics as a service. And now you can name it, anything can come as a service. That means the things are already there. You need to be the chef, master chef, to cook your recipe on these platforms. You have to cherry pick the things, the right things that meets the need of your things. So we call that cloud. So cloud is a big thing, but now it could be defined into various services as a collection of services. That basically summarizes the cloud. So in that light, there are four big cloud vendor. So I would like to say in this platform that our developers should be very much ready from the very beginning on the cloud services, because because in my one of the slides I showed like probably by 2025, 70% of the application will be cloud native or cloud implementation, and probably after that everything will be on the cloud, because cloud is more viable, more maintainable, and the organization are after that. So if we have to develop something or have to really deploy something practically, we obviously think cloud. And in that light, in that manner, as Siddiqui sir also mentioned, that Bangladesh also has a tier 4 data center, which is essentially the cloud services. So you should know what kind of services are available there, and then we should take full advantage of those cloud services. So to get ourselves familiarized with the cloud services, I would like to walk you through some of the services that AWS, which is Amazon Web Services, offer. And in that light, I would just like to have a demonstration on that same token that Tuhin has provided. So in that case, since my work is a data scientist, so I just show you how easy it is to develop a machine learning algorithm from scratch and make a predictive algorithm real time for a medical application. So, and that requires few things as a service I mentioned, like a platform as a service, data as a service, the infrastructure as a service. So I will be talking about the storage, then the compute, and the machine learning, which is analytics as a service, then API gateway. Because as our previous speaker mentioned, if you want to encapsulate your things in a wrapper like API, in this case it's a post API, that will basically don't expose your systems too much. You just tell the API that I am expecting this data to be processed in the backend, and then you get a right response. So it's an API-based development or microservice-based development is very popular nowadays. So we are definitely pitching for that. So API-based development. So I'll just show that because we are running low on time. So I'm just switching my desktop. Okay, so if we, can you see my AWS console? Because I just
not yet.
Okay.
It's different screen maybe.
Different screen. Is it black or?
No, it's still your presentation.
Is things are loading.
It's
presentation.
There,
that means.
Yeah, it
Okay.
Came up. Okay.
Oh, I think probably a delay. Okay.
Your AWS services are visible now.
Okay, so this is basically the portal. Unlike any other cloud provider, AWS is one of them. Like I mentioned, there are mainly four: Azure, AWS, which is like Amazon, then Apple and Google. So in that case, I would say Azure, Amazon is a forerunner of this, but Microsoft is catching up really, really quick. So I have good relationship with both of these technologies, and I have full access to those old technologies. And we are actually, as a customer of health, we have all kind of corporate services offered through them. So we are first-hand experience of those technologies if this is revealed. So in that, just quick give you a rundown summary. So as you can see, compute as a service. So you can see, as Twin mentioned, if you want a virtual machine, you can have hundreds of thousands of virtual machines if you like. Yeah, whatever complex operation is a EC2 instance, which is the elastic compute. So that means elasticity is the backbone of it. So you can get all kind of compute necessity. And this is another called the Lambda. I'll be using the Lambda, which is basically now you don't need a machine to run for 24/7. If you think that your all things could be functionalized. For example, if you want to upload a picture that should be resized and have a creative different size of thumbnail, you don't probably need to run a machine for 24/7 to do that. You just realize those things individual functions and deploy them as a Lambda functions. Then as you invoke this Lambda functions through an API, the machine automatically gets spun up for you and do the job. And if there is a concurrent run of this, you don't get paid for all these runs. So if EC2 is expensive comparing to Lambda, but Lambda is very much like you get as required. So as required compute is a very innovation in this space on the cloud. So this is a kind of a cost-cutting thing. Then you have the containerized. If you have your own containerized application or operating system, you can have your own containerized. And then the storage services, storage as a service. So if you have lots of data, if you have a archive data, there are different kind of S3 Glacier and S3, which is the data source, like a data on the cloud. So if we have our IoT stream is coming through Kinesis, for example, there's an integration things called Kinesis. We can connect these IoT things through the Kinesis services as a stream. That stream gets to the S3 bucket, and then we can process it. So as you can see, I can talk like it probably 4 or 5 days, even not each and every services, but the whole point is it's left to your imagination. Think about virtualizations. Everything is virtualized and everything is there. Even augmented reality is also there. Even game building on the cloud is already there. IoT integration is already built in. As we can see, these are all IoT things, okay? So in that aspect, I would tell you how machine learning is become easier for us to develop on this platform. So in this case, as you can see, machine learning stack, where is that they call it SageMaker. Analytics, I think there is somewhere, so you have the network, the database, Okay, machine learning here. So machine learning, you can see their whole suite of machine learning platforms. So SageMaker is a gateway for that. So I'm using SageMaker to deploy and build anything. So think about our health application that is getting some data. So I just open a notebook, which is running under SageMaker. So imagine our data set is getting people's data like this. So you have your like the patient's so the little bit of background of this solution is basically giving a score when you come to an emergency department with some symptom in a hospital that will tell you whether you get blood infection or not. Okay, so it's a historical data. We have learned it through machine learning. The supervised machine learning algorithm has been used to learn the data from nearly 400,000 record, and using domain expert, the data was labeled since it is supervised learning. And our feature set is very, very minimal. In this case, we see the age, the gender, then so the systolic blood pressure, diastolic blood pressure, their pulse rate, their respiratory rate, their tympanic temperature, and their oxygen saturation. Okay. So using these features, we want to predict whether you are having a blood infection or not, because blood infection is a blind spot in the emergency department, because you may look very healthy, but at the end you may get a blood infection and that may cost your life at the end. So we don't want to do that, because sepsis in Australia is one of the 4th largest killers, and people die of sepsis if not detected earlier. So hospital is investing to have a automated system through AI, and we have IoT integration, because think, when you come, you get your oxygen saturation measured by an IoT device. So we using the Philips device that gets your oxygen saturation, their temperature, your this kind of physiological signs. We call them vital signs. So Philips Vitals has been used, which is an IoT integration, and that gets our data to our medical record, like an EMR. So from EMR, we get the data, and as you can see, this is the raw data set. And as traditional data scientists, as you can see, you do the feature engineering, but I'm showing you only the features, but we have initially like a 200 plus features, but we have omitted those features because those features are not collectible real time. So here is the point. When we build something practical solution, we have to be practical in a sense that we should see what data is available. If you have historical data, that's fine, but in a real-time scenario, on time, what data is readily available and easy to get. So build your model, build your solution onto that space. Otherwise, the solution will have low accuracy, because it may not work, because the data you have based on is a process of some other processing and as a kind of post condition of something. So if that is not met, then you will not get the data. So think wise and do your model based on that. So this is the way you usually do your split of the training, and then this is the AWS like a way of doing this thing. So there are many kind of algorithms of classification. I'm using the XGBoost, which is a gradient boosting algorithm, to classify between these two classes. After doing these things, like you have to deploy this model. So that means you have developed a brain of the system. Like if you go to then now SageMaker, so we have created and trained the data using these like a historical data extract. So after these things, that means we have the training jobs. So as you can see, we have trained these things, like there are some failure training, there's some completed training. That means the training has succeeded. Now, and also not talking about hyperparameter because it's not that technical session. So then once you have done your training, your model is ready to go, then we create an endpoint. Basically, endpoint is the model which is ready to be called from an external system or external, like as a kind of encapsulated manner. So this is basically an endpoint, and we can call that endpoint to invoke it. So there are various ways we can call an endpoint. We can create a API gateway to call this endpoint, or we can write another Python script to run this endpoint within AWS. Then if you get an API, then you can wrap it with like a mobile application like Tuhin has showed through a Node.js. You can invoke the API to, if somebody has their own device at home, then the same features, if you input, then you will get a score. So in this case, a demonstration I would like to show you, like this endpoint has been deployed through a Lambda function, which is here. And I will give you a solid demonstration how that Lambda function could be invoked through an API gateway. So that Lambda function is essentially a serverless application. As you can see, this is like a function I have created, and that function is taking this, taking that endpoint into consideration to be called, and that means when we call this Lambda function, because it is a zip file, probably that's why it will not be loaded. So in this case, configuration, if you select it, I think it should be there. So this is the function. No need, so the function show command. This is a simple code. You can, I'm calling the endpoint of it, and it is expecting some payload as a data. I'm not just printing the payload. So you can test this thing within here. So if I just test it with this data and see I'm invoking the endpoint, it is showing me the alert. It's sepsis alert, means the blood infection disease alert is positive. And this is my payload has been sent through this because if you look at the configuration of it, and this is my data. For example, this is my oxygen saturation. This is my systolic blood pressure, diastolic blood pressure. What the third feature, that is probably the temperature here, the age, some then gender, like that the features I just mentioned. So now these are the data, and then you have written like a Lambda serverless function. And now I'm going to invoke this function through an API. So API looks like this. API gateway. So that is basically essentially calling my the Lambda function I have created. So score sepsis, I just give the API name. Then as you can see, this, if I show you, this is the method, which is any client method. Basically any post office client method can invoke it. Then method request has been sent, and finally it is calling the Lambda function. You get the reply back to the client. So if I want to demonstrate that, how we can do that, so I can show you the post office here. This is the API link, which you can also try if you have a post office. Then this is the link of this, and this is my payload data. Like I'm trying a different set of payload data and try to sending it. And you say no sepsis. This means this doesn't have a score for sepsis. But let's try something else. If I try another new value and just give the payload to that, and then send it again. So this guy is having a positive result, like I say, of sepsis, all because it's a oxygen saturation is a bit low, as we can see. But let's try, even oxygen saturation is also high. So don't think that it's a rule-based system, because even oxygen saturation is low, then definitely there could be infection. But we got something like interesting as well. So if we see oxygen saturation is 100%, and if we see even that also gives us a positive score of sepsis, that means it's a like a multivariable analysis, give a probabilistic distribution behind the scenes that learned the features well as a classification, and then it gave you a like a proper answer. Okay, so yeah, just simply, this is just an example, and I am just I think I have taken much time, so I just don't want to extend my demonstrations much into this space. But in summary, I would like to say, cloud is ready for everything. We just need to think well and come up with the like a problem that we need to solve. Then Tuhin is the solution architect, so he can provide us some kind of solution architect that should be scalable, both horizontally and vertically. Then we have a lot of expertise in the team. They can think about a particular problem that we could say solve as a low-hanging fruit that could readily give benefits to the citizens. They will be living in a smart village. And IT, as I said, is the last thing as an enabler. And as a team, we are confident that we can deliver that. With that hope, I would like to conclude here for tonight. And I'm happy to take any question to be answered. Thank you, Shamim bhai.
And I like to just like give, because last time people were asking like how we can actually, like do some hands-on on cloud. So if you are interested, just contact me. I have like account in everywhere, and I can actually give you some, like
credit.
Like I have Azure, like credit, or I can just give you permission so you can just play with it. Okay. So yeah, I thought I should mention that so people you can just start working with cloud.
Okay, thank you Masum এবং তার যে চমৎকার টিম আমরা মাসুমের কাছ থেকে তার এবং তার টিমের যে এক্সপেরিয়েন্স, তাদের যে হ্যান্ডস অন অ্যাক্টিভিটিস, সেটা সম্পর্কে আমরা ধারণা পেলাম, যেটা আমাদের স্মার্ট সিটি স্মার্ট ভিলেজ ইমপ্লিমেন্টেশনে আমাদের কাজে লাগবে, এবং আমাদের স্টুডেন্ট যারা ছিল আসলে তারাও অনেক কিছু শিখতে পারলো। এবং আমি মনে করি এটা শেষ না, আসলে তাদের ইমেইল অ্যাড্রেস আমাদের কাছে আছে, স্টুডেন্টরা যদি আরো কিছু জানতে চায় শিখতে চায় সরাসরি তাদের সাথে কন্ট্যাক্ট করতে পারবে। আজকে শুধুমাত্র আমরা আমাদের যে স্মার্ট সিটি এবং স্মার্ট ভিলেজ এই বিষয়ে যেহেতু আলোচনা সীমাবদ্ধ রাখতে চাই, এটার মধ্যে আমরা থাকতে চাই। আমাদের যে দ্বিতীয় বক্তা ছিলেন মিস্টার আলাউল কবির স্পিকার, উনি আসলে কোনো কারণে অ্যাভেলেবেল না, তো আমরা এ পর্যায়ে প্রশ্ন নিতে পারি। মিস্টার মুনির চৌধুরীর কাছে যেমন অনেকের প্রশ্ন ছিল, আমরা শুরুতে নিতে পারিনি, এবং আমাদের যে রিসোর্স পার্সোনেল যে 4 জন বিগ বস বলেছি আমি, বস অফ দ্য বসেস, তাদের কাছে আমরা প্রশ্ন রাখতে পারি। এনিওয়ে, আমাদের কোনো প্রশ্ন থাকলে প্লিজ।
Munir, are you still there?
জি, I'm here still.
আচ্ছা, হ্যাঁ, আচ্ছা, আমার ইয়ে হচ্ছে যে you know the climate of Bangladesh, you know, so it rains over 6-7 months during the monsoon season. So now we want to deploy a huge number of sensors on the, say, you know, so there are paddy fields and we need to deploy sensors there. And to be honest, we need to measure or monitor or estimate the required amount of fertilizer. And these sensors have to be in the soil, you know. So, and we need to put a number of sensors so across the field. So depending on the capacity or radius required for a sensor. So now the idea is we want to deploy very cheap sensors, and as you were mentioning, the capacity of these sensors, most of the sensors nowadays, you have some transmission capacity, like you can connect them to Bluetooth or even to your local Wi-Fi, right? So I have no idea how much, I mean, in terms of cost. So then second thing is in terms of the power needed for individual sensors and the ranges of the sensor that can be deployed on the field, and especially taking into consideration that we have to deploy it during the rainy season. You know, it rains over 6 or 7 months in Bangladesh. Only from November, December, January, February, possibly we have bit dry season. So in that case, it will be much easier, but how we can really address these issues about the sensors, their capacities, and connecting them to gateways or any other Wi-Fi, all of these. So what is your experience in these case? Or you have experience in industry aspect, but can we use that experience you have in the industry and go directly to the field in Bangladesh?
Yes, so I think in the last presentation it was mentioned, you know, you started the journey of where you want to go, and then from there you work backwards. So rather than working with trying to identify the specific sensor and then moving outward. So from that point of view, depending on what is it that we want to monitor and what is it that we want to achieve, that will dictate into the technology selection. So I have a experience of the demo that I couldn't show in full time is where we deployed sensors for a water pump that gets bored deep into the ground, and that collects measures the water levels and also the soil quality. Now, the communication there is based on a cellular communication, and one of the challenges we found was that you could get black spots of cellular communication, and in that space, now the device works perfectly okay. The only thing you don't get is the data coming in every now and then. We work around that by either storing that data locally or a time when connectivity is available. It could be as a big batch transmitted, or better still, everyone now has access to a smartphone, for example. And then what we can do is when we have gaps in the data transmission, we can just go to site and pair up that sensor with a smartphone and collect that information as well. So it's like a second path for that sensor. And it's a good idea to have some sort of redundancy built into your system for reliability purpose, because sometimes the data is not so sensitive and it's fine. You don't lose a lot of data, a lot of information. But other times, for example, the use case given about the health, you have data that is required in a timely manner, and so you want to ensure that data gets through. You can create lots of more complex architecture. So you can create more, for example, a mesh technology. So if you don't have access to Wi-Fi, or if you don't have access to local internet, you can create a mesh network. You can create using, for example, a LoRa-based mesh network, and then have a cellular backhaul that takes that information somewhere else. So the technology selection isn't the hardest problem. The hardest problem is understanding what is it that you want to achieve and the environment. So if the environment is very remote, or if the environment is where, also if you think about in a smart village, majority of the users, or sorry, the majority of the people who will benefit from it will be people who haven't had as good an education as the rest of the population. They won't be very technically aware in order to be using those technologies. So you have to make it almost like a black box to them, and
Yes.
in that, and make sure that whatever you're doing, it's just something else that they take for granted. And so in that respect, you have to think about how do you remotely control most things, or remotely manage it, and automate as much as possible. I don't think the technology selection itself is the prime factor in there. Once we can map out the problem space, then the solution itself kind of presents itself almost.
Yeah, thank you very much. So as you said, so idea is, so the farmers don't need to understand the whole thing. All they will get is from the data will come through the sensors to the system will process it, and the system will just prompt the farmer, right? So you need to use this kind of fertilizer of this amount by next 3 days. So that kind of prompt will be given to the farmer. And in the background, it is our team or our specialists will be working. So for every crop, say for the paddy or for the potatoes or for the tomatoes, so in the summer and winter, so they will just switch to potato over the winter, and they will just tap on the screen and the information will be given to them saying in next 3 days you need to really apply this fertilizer to this amount per hectare. So that is the information we are planning to provide to the farmer.
Yeah. Yeah, I mean, you can get sensors that detect, for example, the pH level of the soil.
Yeah, the pH. So we are planning the
you-
pH, say, for example, the soil moisture, and say air temperature, all of these, so that if the air temperature really goes up, so the system will be able to detect, yes, temperature is really high, soil moisture was so that amount 3 days before, now the soil is dry and now you need to put water. So that kind of very simple thing. So we don't want any very expensive thing. So we want a very simple thing to provide very useful information to the farmer. The problem in Bangladesh, there is, it is called Bangladesh Agricultural Development Corporation. They have offices at a district level, and then they have agricultural extension, the small offices at Upojila level. And the farmers, they have to really collect their sample of soils and go to that center and get all these information. So all we want is to make their life easy. So avoid all of this hassle from their life and give them very easy solution. For example, which crop should be suited for this field? Second thing, when will be the right time for plantation or for sowing? And the second thing, monitoring the health of the plant, and then when is the right time for harvesting. So these are the very simple things we want to implement in the smart agriculture, and provide this support to the farmers. So it will be just a simple mobile app like thing, and they will just simply tap on the screen on the mobile and they will get the required information. So you're going to share some?
Yeah, I've shared something. I don't know if you can see something.
It is not yet showing up.
For some reason, when I
Yeah, Zoom is not liking your screen today.
No,
I'm just joking.
no. So in Bangladesh, people, you can now see the way people are exploiting these systems now.
maybe I won't share because when I share, for some reason, my Zoom crashes.
Oh, right. Okay.
Yeah. So yeah. I mean.
This is the plan we have. This is the plan I have in my head. So this is what I want to implement. We don't want to, even we don't need to, even we want to avoid the training of the farmers. So the farmers are intelligent enough to just, if we just show them, you just tap it here. So every detail, there will be some kind of support, and every data or information will be there. That means they have to install the app on their mobile, and there will be some assistance for it, so that they will set all the parameters and everything,
Yeah.
and all the connectivities will be there. So, and they will just tap on the app, and every information will be readily available to them, and even will be able to provide it in Bengali. They don't have to really, even they have difficulty reading it, so we'll be able to give them a mobile message, a voice message. So that is what we have in mind about smart agriculture. And there are other
All very
sectors
doable.
like, yeah. So now what do you think, what will be the cost of these? Say if we just, so we want to set up, we have a plan to set up a small, what should I say, a greenhouse or a field in Khulna University campus with all these sensors and cloud computing and everything. So just we need an estimate so about the sensors and other
Yeah,
thing, just an approximate. Since you have industry experience, possibly you can
yeah.
roughly say us.
Yeah. Well, I mean, if you want to just set up a proof of concept kit without any, you know, if using, you can use cheap Raspberry Pi boxes with some sensor components on it, and you have off the shelf AWS code that you can download from AWS's IoT website for showing how you actually take data from site and put it into cloud. And then once in the cloud, you've seen all of the AWS services, how it works. So doing a proof of concept isn't going to be that expensive. I can't put an exact figure on it because I don't know how things cost in Bangladesh, but it should be relatively simple enough for it to be even a university project, for example. And I know universities are a little bit cash strapped and,
Yeah.
and like to do it on a budget. And
yeah. No, so in pound, say if you just want to really do such thing in your backyard, so how much you think will cost?
Yeah, I think I think if you just take the Raspberry Pi approach, it shouldn't take more than a couple of pounds just to do a proof of concept. You get the sensor.
স্যার আমাদের মনি শঙ্করের বোধহয় প্রশ্ন আছে।
Okay, go ahead. Go ahead, Mani Shankar.
Okay, thank you, sir. So I have a question to the hands-on experience team. So
okay, go ahead.
Yeah, so the presentation was nice and there are many technologies that they have shown. So I just have a little question. So in the context of Bangladesh, which technologies should we learn first, or which technologies are the most important ones for going into or for working on smart city and smart village? So there are too many technologies, everything is needed for us, I know it very well, but which ones are the most important ones? So this is mainly for our students, they can maybe concentrate on this.
মাসুম তুই বলবি, আমি একটু শুরু করতে পারি। মানে আমার আইডিয়াটা সবসময় এই যে যেটা আমি বলতেছিলাম যে টেকনোলজি অ্যাজ এ, মানে যখন টেকনোলজি বলা হয় আমি মনে হয় মণিশঙ্কর তুমি মিন করছো যে আসলে কোন টুলস বা কোন ল্যাঙ্গুয়েজ, তাই না?
হ্যাঁ, আমি সেটাই মিন করেছি আসলে।
সেটাই। তাহলে এইটার আমার যেটা বলা হলো কেউ যদি ওই যে লিটন যেমন কাজ করে খুবই একটা ডিপ লেভেলে একটা স্পেসিফিক এরিয়ায়, ওইরকম হইলে ওই জিনিসটা খুব ইম্পর্টেন্ট। যেমন ওই সব ডিভাইস, যেমন ওই যে মোশন নিয়ে কাজ করে, ওদের ওই যে অনেক মানে বিশেষ করে ফার্মওয়্যার ডেভেলপ করে, তো ওইগুলোর জন্য আমার C++ই লাগবে, ঠিক আছে? কারণ এত লাইট ওয়েট হইতে হয়। কিন্তু এইসব প্র্যাকটিক্যাল এনভায়রনমেন্টে আমার যেটা আইডিয়া, মানুষের চিন্তাটা আগে চেঞ্জ করতে হবে যে আমি আসলে স্ট্যান্ডার্ড গুলো, যেমন আমি একটা সিম্পল এক্সাম্পল দিই, যেমন HTML একটা কি স্ট্যান্ডার্ড, তাই না? কারণ এই HTML-টা আমি কত রকম ভাবে প্রডিউস করতে পারি। একটা ওয়েব সার্ভার লিনাক্সের উপরে থাকতে পারে, একটা উইন্ডোজ বেস হতে পারে, এই যে এখন রাসবেরি পাই আরো ছোট মেশিন। আমি ইভেন একটা ইউজ করছি, এটা হলো আমি ওই আমার আইওটি অতগুলো প্র্যাকটিক্যাল জিনিস করছি আমি, তার মধ্যে একটা কি বলে মাইক্রো কন্ট্রোলার ইউজ করছি, যেটা কিনা ওই রাসবেরি পাই থেকে অনেক অনেক ছোট। ওর মধ্যে একটা ওয়েব সার্ভার রান করতে পারি। তাহলে এখন দেখো এইটা কিন্তু ইমপ্লিমেন্টেশনটা হচ্ছে কি এক একটা জিনিস আসলে অনেক ধরনের ভেরিয়েশন আছে এবং এইটা আমি যেভাবে শিখি সবাইকে আমি ওইভাবে সাজেস্ট করি যে তুমি আগে কনসেপ্টটা বুঝো যে হাউ থিংস ওয়ার্ক। যে এইখানে আমার যেমন আমি যদি আমরা তো আইওটি নিয়ে কথা বলতেছি, যেমন সিম্পল একটা আমি বলতেছিলাম যে একটা সেন্সর আমার একটা টেম্পারেচার নিবে, ওই টেম্পারেচার উপরে বেস করে আমার ডাটাটা পাঠাইতে হবে। এখন আমি এইগুলা বিভিন্ন লেয়ারে ইমপ্লিমেন্ট করতে পারি, তাই না? যেমন ডাটাটা পাঠাবে, সে ফার্স্টে হলো আমার যদি বাড়ির মধ্যে হয় তাহলে আমার চিন্তা করতে হবে এটা কানেক্ট কিভাবে করবো। তাহলে এটা আমার সিম্পল সলিউশন হলো ওয়াইফাই। তাহলে ও যদি ওয়াইফাই দিয়ে কানেক্ট করে তাহলে ওর একটা আমাকে চিনাই দিতে হবে যে এখন এই ডাটাটা কোন পয়েন্টে পাঠাবে। তাহলে আমার কি করতে হবে, একটা এপিআই ডেভেলপ করতে হবে। অথবা আরো ওই যে ডক্টর মুনির যেমন দেখাইছে না যে আমার এমকিটিটিউ, তাহলে কি বলে ওইটা এমকিটিটি আছে, তারপরে আরো অনেক রকম প্রোডাক্ট আছে এবং ফ্রি অনেকগুলো প্রোডাক্ট আছে। আমি যেমন একটা ইউজ করছি ওই এমকিটিটি সার্ভার, আমার লোকাল মেশিনে ইনস্টল করছি। আমি করছি কি আমার ডিভাইস থেকে ওইখানে ডাটাটা পাঠাই দিছি, ঠিক আছে, ডাইরেক্ট। তার মানে কি আমার কোনো ডেভেলপ করতেছি না। তাহলে এইটাই মানে যদি কনসেপ্টটা বোঝা যায় তখন তার সামনে আসলে অনেকগুলো ডোর ওপেন হবে যে আমার তো এইভাবেও করতে পারি, এইভাবেও করতে পারি, এইভাবেও করতে পারি। ওইটাই এইটা হলো আমার আইডিয়াটা আর কি। এখন অন্য কেউ যদি অ্যাড করতে চাও কিছু।
না, আপনার মেসেজটা খুবই ইম্পর্টেন্ট। এটা মেইনলি আমার স্টুডেন্টদের জন্য এটা একটা খুবই ইম্পর্টেন্ট মেসেজ। আমি আপনার কাছে কিন্তু ইন্টারভিউ দিয়েছিলাম। ইন্টারভিউ দিয়ে মানে আপনি এখন যে কথাগুলো বললেন, আপনার কাছে ইন্টারভিউ দিয়ে ওই সময় আমার ঠিক সেই কথাগুলো মনে হয়েছিল যে আসলে কনসেপ্টটা যদি ক্লিয়ার থাকে তাহলে আমরা একটা জিনিস ডেভেলপ করা ওইটা আমাদের জন্য কোনো কষ্টকর বিষয় না। ফার্স্ট উই নিড টু ক্লিয়ার দ্য কনসেপ্ট।
না, মনে আছে তোমার কথা। আমি চলে আসছি,
এটার সাথে আমি একটু অ্যাড করব। আমি এটার সাথে যদি আরেকটু অ্যাড করতে পারি, আর্টিফিশিয়াল ইন্টেলিজেন্স, ডেটা অ্যানালিটিক্স, আইওটি, একটা যেটা what we say is there is a value chain. So there is a value chain from one end to the other. So there is the things side, there is the connection side, connectivity side, there is the middleware, and then there's application side. In terms of technology, there is some overlap, but you'll find that at each of the value chain, there are certain types of technologies that are more applicable than there are in other cases. For example, if you're doing C, C++, that's more applicable on the device side, and you need to understand more from an embedded perspective. Whereas if you're applying C++ and Java, you don't need to understand the embedded side aspects of it for if you're trying to create a web application or a mobile application. So the what you need to learn and how you need to learn it will very much be dictated by where in the value chain you're trying to come in. If you want to be a generalist, of course you can be a generalist and you'll get some experience. But to really understand and put that impact on it, you need to come in at you need to understand where in the value chain you want to have the most impact.
Yeah, it's a very
আমি যে একটা এক্সাম্পল দিয়ে দিই, কারণ আমি যখন ওই যে আমার হোম অটোমেশন করছিলাম, ফর এক্সাম্পল যখন মাইক্রো কন্ট্রোলারের জন্য আমি একটা প্রোগ্রাম লিখছি, ওইটা লিখতে হয়েছে আমার বেসিক সিতে, কারণ ওইটাই সাপোর্ট করে, ঠিক আছে। আমি যখন আমার ওয়েব সার্ভিসটা লিখছি তখন আমি লিখছি C++, ঠিক আছে। আমি যখন একটা মোবাইল অ্যাপ বানাইছি ওইটা লিখতে হয়েছে সেই যে অ্যান্ড্রয়েডের যে ল্যাঙ্গুয়েজ, ওটা জাভার কাছাকাছি, ঠিক আছে, ওইটাই। তাহলে দেখো কয়টা টুল লিখছি। তারপরে আমি মিডল ওয়্যারটার জন্য আমি ওই যে রেডিমেড একটা এমকিউটিটি সার্ভার, ওইটা আমি অন প্রেম ইনস্টল করছি। ওইটা ইচ্ছা করলে আমি ক্লাউডেরটা ইউজ করতে পারবো। তাহলে ওইটাই বললাম যে কনসেপ্টটা যদি ক্লিয়ার থাকে, এই দেখো আমার সামনে যেটা ওই যেটা ডক্টর মুনির বললো যে অনেক সময় বাউন্ডই তুমি, কারণ একটা ডিভাইসে কাজ করতে গেলে সাপোর্টই করে সি, আর কিছু অপশনই নাই। আর অনেকগুলো আবার অনেক অপশন আছে।
এক্স্যাক্টলি।
হ্যালো স্যার, আমার মনে হয় যে অস্ট্রেলিয়াতে যারা আছে ওদের মানে সময়ের কোনো আছে কিনা টাইম? কারণ
না, ওদের নাই, ওরা
স্যার অলরেডি এক্সস্টেড হয়ে যাওয়ার কথা।
আমি তো সেই 3:30 থেকে আমাকে 3:30 থেকে আছি। এটা হচ্ছে ইওর ইন্টারেস্ট।
হ্যাঁ স্যার, এমনি যেহেতু স্বামী মডারেটর ছিল, আমি পাশে বসে আমরা আসলে একটা কম্পিউটার শেয়ার করছিলাম, এজন্য আমি কথা বলিনি। আমি এই দুইটি ডক্টর মুনির এবং মাসুম, লিটন, জিলানি, তারপরে তুহিন, এদের সবাইকে বা আমার ডিসিপ্লিনের পক্ষ থেকে অনেক অনেক ধন্যবাদ জানাই যে এই থার্ড সেশনটাকে এরকম একটা ইফেক্টিভ অনে পরিণত করার জন্য। তো স্যার আজকে আমরা মনে হয় আস্তে আস্তে বিদায়ের দিকে যেতে পাই, কারণ মানুষ
হ্যাঁ না এটা ফর্মালি ক্লোজ করে দাও, তারপরে যারা থাকবে
আমার একটা কোশ্চেন ছিল স্যার।
হ্যাঁ আচ্ছা বলো।
সরি আনিস ভাই, একটা কোশ্চেন আই হ্যাভ টু Dr. Munir. As I said, I have some occasional experience programming with IoT devices for my projects. So the development cycle is different for IoT than usual software development. As I can tell you, 2 years ago when we graduated, we have resource limitation when we were programming in some software. It was all about memory, hardware, I mean storage or something like that. But nowadays with cloud, we don't have any resource limitation in that respect. But if we think about IoT, we still have this limitation in Bangladesh. I mean, in software, we usually develop, we break, we debug, we fix the problem. But I have experience with IoT device that burned the devices, some sensors, and I couldn't use it anymore, for example. So I'm just curious to know, is there any solution for our students here who don't have enough money to buy these sensors or other IoT devices to learn the technologies and then again break and continue? Do you have any idea, or is there any technologies to overcome this type of problems?
Yeah, so from a learning and experience the concepts point of view, I think both Amazon AWS and Azure have got platform capability where you can create simulations of devices, and you can apply like MQTT to their IoT services and see what happens. So you don't actually need a physical device from a learning perspective for experience how IoT works. Of course, you know, you're not generating real quality data, but that to get started, you can do that. You can also, I know, you know, Raspberry Pis are cheap in Australia and in the UK and things like that. But you don't need to go even to the Raspberry Pi level. You can buy much cheaper microcontrollers that are like $10 or $5. They are more constrained, but they do also have already built-in code for IoT connectivity. If anyone wants to know of any of such devices, I'm happy to connect and provide some details around that. I don't have it straight off the top of my head, but I can certainly give, you know, provide some details on that.
I think Adriano, Adriano is the cheapest one.
Sorry, what was the question?
No, I was just saying, like, was it Adriano or Adriano? Like, what is the name?
Arduino, Arduino. Yeah, even Arduino is on a par in terms of cost with a Raspberry Pi. Arduinos are a little more complex to control, but they are cheaper, but they're still for some it could still be a bit cost prohibitive. So yeah, you can get little microcontrollers. You can get little Bluetooth tags, for example. You can get Bluetooth tags that can connect to your, I mean, one of the sites that I like to go online is go to AliExpress online, and there you can find for $5 or even less some small sensing device, and you can experiment with those. They come with the code built in. Some of the companies they give code for it, so that you can change it. Yeah, you can experiment it in that kind of way.
থ্যাংক ইউ। আমরা শেষ প্রশ্ন হিসেবে মোহাম্মদ গোলাম জিলানির প্রশ্নটা নিচ্ছি।
No, actually আমি প্রশ্ন করতেছি না, আমি just adding something on to him, just for the Manishankar and all other students. From my experience, I have seen that since the context of smart city and smart village, we are thinking, and this is kind of thing which we can see that comes from the data-driven application. So, from my practical experience, I have seen that Python is one of the tools which can which students should emphasize in a first glance, because using Python you can do a lot of data problems from the data scientist. Okay.
আচ্ছা, আমার মনে হয় আমরা এখন শেষ করতে পারি। আমি প্রথমেই যে আমাদের যে থার্ড সেশন এটা আমাদের যে স্পিকার ছিলেন বিশেষ করে ডক্টর মনির চৌধুরী এবং আমাদের যে রিসোর্স পার্সোনাল লেড বাই মাসুম, সবাইকে ধন্যবাদ জানাচ্ছি, বিশেষ করে সময় বের করে আমাদের, যদি অস্ট্রেলিয়ান টাইম ইউরোপিয়ান টাইমের সাথে বাংলাদেশ টাইমের আসলে কিছু প্রবলেম আছে, তারপরেও সময় অ্যাডজাস্ট করে আমাদের সময় দিয়েছে, আমাদের অনেক মূল্যবান অভিজ্ঞতা থেকে মূল্যবান তথ্য আমাদের দিয়েছে, যেটা আমাদের এই স্মার্ট সিটি ইমপ্লিমেন্টেশনে কাজে লাগবে। আর স্যারকে আসলে আর ধন্যবাদ দিয়ে ছোট করতে চাই না, যে আমরা এখনো আসলে অনেক হয়ে যাই, টায়ার্ড হয়ে যায়, কিন্তু স্যার সেই সকাল 3টা থেকে এখন পর্যন্ত যেইভাবে শক্তি নিয়ে আমাদের স্যার উল্টো করে আছে, শক্তি যোগাচ্ছে। স্যারকে অসংখ্য ধন্যবাদ। এবং আমাদের বিশেষ করে স্টুডেন্ট যারা, তারাও অনেক ধৈর্য ধরে আমাদের এই সেশনে তাদের বক্তব্য শুনেছে। আশা করি এটা তাদের প্র্যাকটিক্যাল লাইফে কাজে লাগবে। এবং আমি সবাইকে, আমাদের একজন স্পিকারও আছে গত সেশনের, তহিদ আমানুল্লাহ, ইউরোপ থেকে আছে, সেও আসলে ধৈর্য ধরে আছে আমাদের সাথে। আমি সবাইকে সিএসসি ডিসিপ্লিনের পক্ষ থেকে, খুলনা বিশ্ববিদ্যালয়ের পক্ষ থেকে ধন্যবাদ জানাচ্ছি। এবং স্যারকে আসলে আমি কনক্লুডিং বক্তব্য 2-1 মিনিট স্যার বলে শেষ করে দেন স্যার, প্লিজ।
থ্যাংক ইউ ভেরি মাচ। যে সবাইকে especially my special thanks to Dr. Munir Chaudhary, ধন্যবাদ, it was a very useful। আর আমাদের এই 9-4 ব্যাচের 4 জন, ওরা আমাদের এই স্মার্ট সিটি স্মার্ট ভিলেজের একেবারে অগ্রসৈনিক।
স্যার আজকে আরেকজন ছিল স্যার, আজকে বিশ্বজিৎ মল্লিক ছিল, সেও 9-4 ব্যাচের।
হ্যাঁ, 9-4 ব্যাচের, সেটাই বলতেছি, সবাই তো ছিল, কিন্তু এই বিশ্বজিৎ ওই প্ল্যানিং এর থেকে, কিন্তু সিএসসির এই যে এই ক্লাউড কম্পিউটিং আইওটি নিয়ে তোমাদের এই এদেরকে বলতেছি যে থ্যাংক ইউ ভেরি মাচ। আর 9-4 ব্যাচের আসলে চারিদিকে এই যে আমাদের মোর্শেদ ডুজেলডর্ফ থেকে ও 9-4 ব্যাচের, লেনিন 9-4 ব্যাচের, প্রতীক 9-4 ব্যাচের, এবং সবই চারিদিকে দেখি শুধু 9-4 ব্যাচ। কাজেই তোমাদের সবাইকে অসংখ্য ধন্যবাদ। আমাদের আগামী মাসের মার্চের, এটা হচ্ছে 27শে মার্চ শনিবার, এটা হোস্ট করবে হচ্ছে চট্টগ্রাম ইউনিভার্সিটি অফ সায়েন্স, ইউনিভার্সিটি অফ টেকনোলজি, ইঞ্জিনিয়ারিং অ্যান্ড টেকনোলজি, চুয়েট অর্গানাইজ করবে। আমাদের মশিউল আজকে আসতে পারিনি, কিন্তু আরেফিন ছিল, তো ওটা ওরা হোস্ট করবে। আমি সবাইকে অনুরোধ করব যে আবারও যে এটার সাথে থাকা। আর দ্বিতীয় যে জিনিসটা আমি এখন একটু কনক্লুড করব, আমাদের আজকের পরে যেটার কথা ছিল যে আমরা একটা ফান্ডিং এর অ্যাপ্লিকেশন তৈরি করব, একটা মডেল স্মার্ট ভিলেজ জন্য আমরা একটা ফান্ডিং এর অ্যাপ্লিকেশন করব, সেটা খুলনা ইউনিভার্সিটি, কুয়েট এবং যশোর ইউনিভার্সিটি মিলে। তো এই ফান্ডিং এর প্রিপারেশনটাও আমাদের নিতে হবে। এই প্রিপারেশনের জন্য আমাদের আরেকটু ডিটেলসে ওয়ার্কআউট করতে হবে। সেটা করে আমরা আশা করি এই 1 মাসের ভিতরে সবাইকেই আবার একটু বিরক্ত করব আমি, যে এই ফান্ডিংটার অ্যাপ্লিকেশনে একটু কন্ট্রিবিউট করার জন্য। এটা সবার কাছে আমার অনুরোধ থাকবে। আর একটা জিনিস, মাইনুল আছে এখানে অ্যালামনি থেকে, সে যথেষ্ট ফান্ডিং এর নিয়ে চেষ্টা করতেছে। আমাদের টার্গেট হবে খুলনা ইউনিভার্সিটির ক্যাম্পাসে সিএসসি এরকম একটা কি বলবো, একটা গ্রিন হাউসের মতো একটা করবে, যেখানে যতদূর সম্ভব সেন্সর লাগানো হবে, আইওটি ডিভাইস লাগানো হবে, এবং ক্লাউড কম্পিউটিং দিয়ে এই সিএসসি ডিসিপ্লিন থেকে এরকম একটা এটাকে বলবো কি, এটা একটা এক্সপেরিমেন্টাল সেটআপ তৈরি করা, যেখানে আমরা স্মার্ট এগ্রিকালচারটাকে ডেমনস্ট্রেট করতে পারবো। এটা আমার মনে হয় এটা করলে ভালো হয়। এটা আমরা এই মাসে এটা ওয়ার্কআউট করব। আর এখানে মাইনুল যেহেতু আছে, আমার কথা হলো কারো কাছে আমরা হাত পাততে যাব না, আমাদের যা সামর্থ্য আছে সেটা দিয়ে করব। আর যেসব নর্মাল মেকানিজম আছে সেই মেকানিজমে আমরা ফান্ডিং এর অ্যাপ্লিকেশন করব। আইসিটি মিনিস্ট্রি, A2I, টেকনোলজি মিনিস্ট্রি, সব জায়গাতেই ফান্ডিং এর অ্যাপ্লিকেশন করার স্কোপ আছে, আমরা সেগুলি করব। প্লাস বিশ্বজিতের সাথে এটাও কথা হয়েছে যে ইউরোপিয়ান ইউনিয়নের ফান্ডিংও আমরা অ্যাপ্লাই করতে পারবো। কাজেই তার আগে ফান্ডিং অ্যাপ্লাই করার আগে আমরা নিজেদেরকে একটু গুছিয়ে নিতে হবে। প্লাস বিশেষ করে সিএসসি যে পাবলিকেশন দেখলাম, এটা তো অ্যামেজিং, অনেক ভালো পাবলিকেশন, এবং বাংলাদেশের খুলনা ইউনিভার্সিটি বসে সব পাবলিকেশন হচ্ছে। এটি যথেষ্ট একটা ইউরোপিয়ান ইউনিয়নের ফান্ডিং ধরার জন্য, কোন ইউনিভার্সিটি কোলাবোরেশন করার জন্য এই রিসার্চ ব্যাকগ্রাউন্ডটাই আমাদেরকে হেল্প করবে। সো আশা করি যে আই এম সো গ্রেটফুল টু ইউ অল, যে আমার এটার জন্য তোমরা মাস ধরে এভাবে প্রস্তুতি নিচ্ছ এবং এটা নিয়ে কাজ করতেছো। উদ্দেশ্য একটাই, কিছু করা। অতিকায় হস্তি লোপ পাইয়াছে, কিন্তু তেলাপোকা টিকে আছে। সেই তেলাপোকার মতো যাতে আমরা টিকে না থাকি, কিছু করা, এবং মানুষের জন্য কিছু করা, সমাজের জন্য কিছু করা, দেশের জন্য কিছু করা। আমার মনে হয় এটাই হওয়া উচিত। খুব সিম্পল একটা ফিলোসফি যদি লাইফে কারণ থাকতে হয়, এটাই থাকা উচিত, কিছু করব। আজকে আমার এখানে নাই, এই যে আমরা সেফটি পিন, এক্সকিউজ মি, সেফটি পিন ইউজ করি, এই সেফটি পিন, আজকের যেসব সেফটি পিন আমরা ইউজ করি, এটা 1849 সালে এটা প্যাটেন্ট করা হয়েছিল। গ্রুভার, সে একজন মেকানিক্যাল ইঞ্জিনিয়ার। দেখো 170 বছর হয়ে গেল, এই সেফটি পিন এখনো বেঁচে আছে এবং মানুষ ব্যবহার করছে এবং তার নামটা বেঁচে আছে। তার মানে আমরা যে একবার রকেট ইঞ্জিন আবিষ্কার করে ফেলবো, এটা দরকার নাই। আমরা ওই সেফটি পিনের মতন, ওই জেমস ক্লিপের মতো ছোট্ট একটা কিছু করি, যেটা মানুষের কাজে লাগে। এই যে জেমস ক্লিপ, যেটাকে আমরা পেপার ক্লিপ বলি, 1896 সালে এটা প্যাটেন্ট হয়েছিল। এখনো কোটি কোটি মানুষ এটা ব্যবহার করতেছে। থিঙ্ক সিম্পল and try to implement it. এটাই তোমাদের কাছে আমার মানে অ্যাপিল। Just this is my appeal to you. Let us do something together, and together we can do more. Thank you very much.
ধন্যবাদ স্যার। আর শেষ সময়ে জাস্ট একটা মন্তব্য না করলে আমি সম্পূর্ণ হচ্ছে না, সেটা হচ্ছে যে তৌহিদ আমানুল্লাহ ইউরোপে বসে যেভাবে সমন্বয়ের কাজটা করেছে, আমাদের নাসিম, তারপরে আমাদের ডিপার্টমেন্টে মণিশঙ্কর, অতনু, যারা বক্তব্য দিয়েছে তারা তো দিয়েছে, কিন্তু ব্যাকগ্রাউন্ডে বেশ কয়েকজন শিক্ষক অনেক পরিশ্রম দিয়ে সামনে থাকি আমি বা শামীম, কিন্তু পিছনে আসলে অনেকেরই শ্রম আছে। একটাই কারণ, সেটা হচ্ছে যে সিদ্দিকী স্যারকে সবাই ভালোবাসে এবং তার স্বপ্নের সাথে একাত্ম হতে চায়। তো আমরা স্যারের স্বপ্নের সাথে থাকবো ইনশাল্লাহ। তো সবাইকে ধন্যবাদ। এই আমাদের যে দীর্ঘ সময়, আসলে সকালের সেশন এক্সপেকটেশনের চেয়েও 1-1.5 ঘন্টা বেশি হয়েছিল, আবার এই সেশনটাও 1 ঘন্টার বেশি অতিরিক্ত আমাদের ছেলেরা যে ধৈর্য ধরে আছে, আমি তাদের সবাইকে ধন্যবাদ জানিয়ে স্যার এখানে শেষ করছি। স্যার ভালো থাকবেন, আবার কথা হবে ইনশাআল্লাহ ডিটেইলস।
আচ্ছা, থ্যাংক ইউ।
আসসালামু আলাইকুম।
ওকে,